Let's see about evaluating this limit. We know secant is 1 over cosine x. The cosine at pi over 2 is 0, so we have 1 over 0, which goes to infinity. Denominator, we have 1 plus tangent, which is sine over cosine, so we have the same kind of an issue of it is going towards infinity then as the denominator goes to 0. So we do have an indeterminate form, infinity over infinity. We could do some algebraic manipulation, or we could apply L'Hopital's rule, and that's what we're working on in this section, so that's the way we're going to do this one. So we know that this limit equals the limit as x approaches pi over 2 of the derivative of the numerator. The derivative of secant x is secant x tangent x. The derivative of the tangent is secant squared. Now we can go ahead and reduce by a secant here, and then we actually could do some more simplifying of this because we know tangent is sine x over cosine x, and secant is 1 over cosine x, so we could flip this one over to multiply, and then these would reduce. So we have the limit as x approaches pi over 2 of sine x, and we know that that is 1. Let's look at our second limit here that involves trig functions. We have the limit as x approaches pi from the left-hand side. Well, the sine of pi is 0. Cosine of pi is -1. And so we could work this and have 0 over 2. It is not indeterminate, so we would not apply L'Hopital's rule. And it's always good to look at these because you get so happy applying the rule that sometimes forget to double check and make sure we do have an indeterminate form before we use the rule. So we have no need of using the rule here because the denominator is not 0. Okay, let's look at another one. As we let x approach 0 here, we have 0 minus 0, or 0 over 0. So we do have an indeterminate form. We can apply L'Hopital's rule and have the limit as x approaches 0 of 1. The derivative of sine is cosine, so minus cosine x over 3x squared. And if we let x approach 0, the cosine of 0 is 1, so we have 0 over 0, indeterminate form again. So we can apply L'Hopital's rule again and have the limit as x approaches 0 of the derivative of negative cosine is going to be sine x over 6x. We can see we still have the indeterminate 0 over 0. Let's apply L'Hopital's rule again. And the derivative of sine is cosine and over 6. And we now stop because the cosine of 0 is 1 and the denominator is 6. Looking at this next one, e to the 0 is 1, and 1 minus 0 minus 1 is 0 over 0. So we do have an indeterminate form. We can apply L'Hopital's rule. This equals the limit as x approaches 0 of the derivative of the top, which is e to the x minus 1, over the derivative of the bottom, which is 2x. E to the 0, 1, we still have an indeterminate form because we have 1 minus 1 there on the top, so we have the limit as x approaches 0 of e to the x over 2, and then we can now directly evaluate. E to the 0 is 1 over 2, and our limit is 1/2.